Okay, this is your Unit 2 test review, and I'm going to work out all the problems for you. I'm going to go pretty quickly, but if you need to, just pause and go back and watch. And also, I would think about chunking this video so you don't sit and watch the whole thing at once. So first of all, number one, remember what the directions are telling us to do. It's saying to simplify, and it says to simplify the expression. Remember, the expressions do not have equal signs. I'm not going to have x equals or y equals in any of these things. It is just simplifying it from a long sentence to something much shorter. So to do number one, I'm going to circle my integer that I am going to distribute over to the 3x and also to the -1. If you want to circle these two, that's fine. We have a negative times a positive. That gives me a negative. We have 3x, so that's minus 12x. 3 times 4 is 12. And I have a negative times a negative, which gives me a positive. And 4 times 1 is 4, minus 2x. Again, no equal signs. I'm just combining. I distribute, and then I'm going to combine like terms or simplify, because that's part of my directions here is to simplify. I'm going to combine the 3x minus the 12x and minus the 2x. That's going to give me negative 11x. I could also think about the negative 12x and the negative 2x. That gives me negative 14x. And then 3x minus 14x gives me that negative 11x. And the only thing I have left is right here, so that's a plus 4. So this here is my final answer, negative 11x plus 4. Number two, we do have a fraction outside, but think carefully what you're doing. You don't need to try to get rid of it, because we're just going to go ahead and multiply by the negative 1/4 by the 8, or the negative 8. So this gets distributed to the negative 8. And if you think about it, if you think of a quarter of 8, that would give you 2. If you took 8 and divided it into 4 things. Also, if you want to think about it, it's 1 over 4 times 8 over 1. And then that becomes 8 over 4, which becomes 2. Or you can also simplify before you multiply. That becomes 1, that becomes 2. And you're still going to wind up with 2 over 1, which is 2. But again, it was a negative times a negative. That gives me a positive, so it's 2. And now I have the negative 1/4 times a positive y. That's going to give me a negative 1 over 4y. Because I can't multiply the or the number, the negative 1/4 and the y. I just have to put them together. This here is my answer. You could also rewrite it to have the variable first, which is really the more proper way to do it. So you have 1 over 4y plus 2. Either one of these answers I would accept on a test. So on the next one, number 3, we're going to combine our like terms first of all. I have a negative 2a and I have a positive 2a. Well, I know they cancel each other out, because a negative 2 and a positive 2 becomes 0. So I'm just going to go ahead and do that. The only thing I have left here is the negative 4a right here. So I have negative 4a. And now I have 6, and you can either use another color or you can underline or do another symbol. So I have 6 plus 3, and that gives me 9. So it was negative 4a plus 9. And that's my answer here for this one. Next one here, again, we have to distribute. We've got a positive 4. Don't forget your sign goes to the positive 2x. So we have x. A positive times a positive here is a positive. So that's plus 8x. And then we have a positive times a negative. That's going to be a negative. And 4 times 9 is 36. And now I'm going to combine my like terms. I have an x and I have an 8x. That's the only thing I have alike here. So now, remember this is a 1x if you want to think of it. 1x plus an 8x is 9x minus 36. And so this is my answer here for this one. Number 5, this time now we're actually solving equations. So we actually have an equation to solve. Now, this one, a lot of people say, oh, I want to get rid of my fraction. We don't need to do this first on this one. Number 6, I would say yes, but number 5, we don't really have to. Because all I'm going to do is get rid of my 6 to begin with. Because remember, I'm getting rid of anything that's alone that's not with a variable. X over 3, the 3 is kind of with the x, so this is alone, it's gone. So I have x over 3, or x divided by 3, is equal to 3. Because negative 3 plus 6 is 3. And now what I'm going to do is get rid of the 3 under the x, because it's x divided by, remember this here means divided by, x divided by 3. So to undo it, I multiply by 3. And I can multiply both sides by 3, and then this cancels out, and I have x all by itself. And 3 times 3 is 9. This time I do have my equal sign. I do have x equaling something. I'm going to strongly urge you, ladies and gentlemen, to plug numbers back in every time you get a number for a variable. I'm going to do it with this one, but you need to make sure you do it with all the other problems, especially on your test. What I would do is do all of my test questions. When I'm done and I have time, then I'm going to go back, so I'm going to pretend I'm all finished. I think that x is 9, so I'm going to plug in 9 where I see x. That means 9 divided by 3 minus 6 is equal to negative 3. 9 divided by 3 is 3. 3 minus 6 is equal to negative 3, and that is a true statement because 3 minus 6 is negative 3, and negative 3 does equal negative 3. That checks out. That means this checks out. Make sure your answers do check. This is the beauty of algebra and the beauty of solving equations is you will know automatically if your answers are correct. All right, this one here, I think I will go ahead and get rid of my fractions to begin with because I can do this by using the least common multiple or the least common denominator, whichever one you want to call it. I have a 2 and a 3, so my least common denominator is 6. That means I'm going to multiply every single term in this equation on both sides of the equation and every term by 6. So again, if you need to do the actual math on this, you might want to do it off on your own paper. 6 over 1 times, or scratch paper I mean, times 1 over 2. This becomes 6 over 2, which is 3. So this first part here becomes 3m. The second part there, we have 1 over 2 times 6 over 1. I'm sorry, 1 over 3. Let's try that again. Sorry, we have 6 over 1. That was our outside number times the negative times negative 1 over 3. And this is going to become negative 6 over 3. And so that's going to become a negative 2m. Again, you could simplify before you multiply if you wanted to, though. 3 becomes 1, 6 becomes 2. Over here, this becomes 1, this becomes 3. And then 3 times 1 is 3, because it was actually, wait a minute, it was 6 over 2, sorry. And we were making that down to 3. I was looking at my 6 I was multiplying by, sorry. All right, so I have this 2 done. I have to also multiply this by 6. So it's a positive 6 times a negative 2. That gives me negative 12. And I have to multiply this by 6. That equals 60. Okay, once I do all that, now I can combine my like terms. And so to do that, this is going to be 3m minus 2m. That gives me 1m. I don't need to put the 1 in front of it. Minus 12 is equal to 60. Now I'm going to add 12 to both sides to get rid of that. And my m is equal to 72. And that's my answer there. Again, I would check my answer when I can, just to know that I did get it right. All right, solve the equation. Again, we're going to distribute first. So I have a negative 3 times an x. This gives me negative 3x. And a negative times a positive is a negative 12. 3 times 4 is 12. I still have a minus 14 equals 7. All right, these I can combine, the negative 12 and the negative 14. So a negative and a more negative is just more negative. So negative 3x. This is going to be minus 26 is equal to 7. I'm going to add 26 to both sides. I'm going to move up here. Negative 3x is equal to 33. I'm going to divide both sides now by negative 3. And a negative divided by a negative is a positive x, which is what I want. But a positive divided by a negative gives me a negative 11. The biggest thing here, ladies and gentlemen, watch your signs in all cases. Watch your signs when you're distributing. When you get your new numbers, make sure you're just watching your signs. All right, solve the equation. This one trips people up because they look the same. We have negative 2x plus 2f plus 10 is equal to 2f minus 10. The thing is, they're not actually the same thing, so you got to watch what you're doing. I like to get rid of my any variables that are on the right-hand side, so I'm going to get rid of this one here by minusing 2f, because that was a positive 2f. 2f minus 2f gives me 0, so that cancels out. But I'm also going to minus 2f on this side. Now, if you wanted to, you could have done an add 2f to both sides, and your f's would have been on the right instead. But I have a negative 2f minus 2f. That gives me negative 4f. Plus 10, so I have the plus 10. This part canceled out, and I have a minus 10. All right, now I'm going to get rid of this plus 10 by subtracting 10. If I subtract from one side, I must subtract from the other side. Now I have a negative 4f is equal to negative 20. All right, now it's just a one-step equation here. I'm going to divide both sides by the negative 4. And A negative divided by a negative is a positive, so my answer is F is equal to 5, because again, 20 divided by 4 is 5, and a negative divided by a negative was a positive. All right, next one, number 9. We have, we're writing it as a algebraic equation. There's a couple ways you could write it. 6 more than. So what we're saying here is we're doing something about adding, because the more than part, that's my adding. So we have 6 more than. 6 more than. 3 times a number. Okay, 3 times the number means 3x, because some number, this here is going to be x, and this is 3 times whatever that is. So this is 3x. Is 12. Remember, this word is my equal sign. So that's is, and then 12, of course, is my number. So I can have it like this. My thing is, though, to me, if it says more than, I actually think that should come second, because I'm saying I have more than something that's already there. So that 3 times the number actually, to me, should be first. And then we're going to add the 6 is equal to 12. But either one of those answers would be correct on a test. Okay, this one here, we're using the equation to model the, using the model in the box to create an algebraic equation and then solve for x. So with this one, we have a key up here, and that's what we need to make sure we're watching out for, is to see what the key is standing for. So I'm going to go ahead and just start with all the positives on one side. So a lot of you like the river or the line or the wall, whatever you want to call it. So I'm only going to look on the left-hand side for right now. I have 1, 2, 3, 4, 5 x's that are represented by this bar right there that said x's are this. So I have 5 of them. That means I have 5x for that. Now I'm going to do the negatives, the negative x's. This is a negative x, and I'm going to just go ahead and still put x. 1, 2, 3, 4, 5, 6, 7. So those are negatives, so that's going to be minus 7x. And now I have my little squares that represent 1. So I'll start with my positives. I have 1, and that's it. I have plus 1. So I'm going to add 1. And now I also have minus 1s. 1, 2, 3, 4, 5. So that's minus 5. Okay, that's on that side. Now I'm going to look at the right-hand side, do the same thing. I'll start with the, doesn't really matter where you start, by the way. I'm going to start on this one with the negatives. So I have 1, 2, 3, 4, 5. So I had 5 negative x's, so negative 5x. I have 1, 2 positive x's, so that's plus 2x. I have 1, 2, 3, 4, 5, 6, 7 negatives, so that's minus 7. And then I have 1, 2, 3, 4, 5, 6 positives, so that's plus 6. All right, now I got to do some combining like terms to get my equation into a more manageable thing here. So I have 5x minus 7x, that gives me negative 2x. I have a plus 1 minus 5, that gives me a negative 4. I'm going to bring my equal sign over here. I'm sorry, I'm not keeping it lined up. I'm running into my little thing here. So we have a negative 5x plus 2x, that gives me negative 3x. Then I have a negative 7 plus 6, that gives me a minus 1. All right, I'm going to, again, I like to move all my variables to the left-hand side, so I'm going to get rid of my negative 3x by adding 3x to both sides. Again, if you didn't want to do that, you could have added 2x to both sides, and your variable would just be on the right is all. This becomes x. This cancels out. I get x minus 4 is equal to negative 1. I'm going to add 4 to both sides to get rid of the 4. And now I get x is equal to 3. So I had to do 2 parts there. I had to create the algebraic equation, so I have my equation, and then I also solved for x. So I've done both of those things. Okay, number 11, it says that Brianna wants to buy a new phone for $1,000. She has $200 and plans to save $50 each week. How many weeks will it take her to save the money? All right, so one of the things you could do is just kind of do the math. If we have $1,000, we can get rid of $200. That means she has to save up $800, and then you could figure out how much it would take to do that. But remember, we are talking about equations, and so let's go ahead and set up an equation to do it. If I already have $200 saved, if I'm Brianna and already have $200 saved, I've got to, that's going to be a plus 200. Because I want whatever my equation on the left-hand side here, I want it to equal this here. This is my total I need. So I want it to equal $1,000. Okay. She plans to save $50 each week. That means $50 per week. Well, I don't know how many weeks, so that's going to be my variable. This is my variable, so weeks equals W. So we have W. I'm sorry, wait. I don't want it there. Sorry. We're going to take $50 a week, which means we're doing 50 times each week. So 50 per week or each week. So this is 50x. So when I solve this equation, I'm going to know how many weeks it's going to take her to do this. I'm going to minus 200 from both sides. So now I have 50x is equal to 800. I'm going to divide both sides by 50. And then I get x is equal to 16. Remember, though, you have some units here. It's weeks. Our W is referring to weeks. So it's 16 weeks. Sorry, that it does say weeks, okay? But that is my answer there. X is equal to 16 weeks. Or you could say it will take her 16 weeks to save the money, something like that. All right, this one here, we're writing it in words. And there's a lot of ways you could do this. On this one, basically what I'm going to say is we have a minus 1 here. So what I'm going to do is I'm going to say 1 less than. 1 less than all of this here. So 1 less than, because that's my minus part. And then I look at this part here that I'm looking at. This is what we call a quotient, because it's a division problem. So it's 1 less than the quotient . 1 less than the quotient, and I have to say this in order. A number divided by -3, because the number's on top, so that's first. A number divided by, this is my number, divided by -3. So that's how I'm going to write it. The quotient of a number and -3. Because when I say the quotient of a number and -3, that means that number's first and it's divided by the -3. And then I have my equal sign, so I could say equals, I can say is the same as. There's a lot of things to say there. I'm going to write is the same as. And then this number here is -8. So I just write it like that, -8. Again, a couple ways you could do it, but you do need to just make sure you're doing it correctly with the wording. All right, solving the equation here. Again, this is one that I'm not going to worry about getting rid of the fraction, because when I distribute, it's going to get rid of the fraction pretty easily all by itself. So we have 4/7. Actually, let me do it a little bit higher, just because this part you can really kind of do on your scratch paper. I'm distributing 4/7 to 7. 4/7 times 7/1. So again, I can do 4 times 7 is 28 divided by 7, or I can simplify before I multiply and I get 4. So this is 4k. And then the same thing with the 4/7 times -21/1. I can simplify, that's 1, that's 3, so that's going to give me -12. Or if you multiplied, you're going to have the 4 times 21, and then you're going to divide it by 7. You'll still get -12. We have this is equal to 3k. All right, now this part's a little tricky. I still like to move all of my variables over to the left. And if you didn't, you could move the 4k to the right, and then it'll be just a little bit different problem. But I'm going to get rid of my 3k, because this might happen in some other problem you might do if you chose to do it this way. Okay, 4 minus 3k is just k, because it's 1k, I just need k. Minus 12. Now we got to remember, 3k minus 3k is equal to 0. I do need my 0 there. Usually I don't put a 0, but I need to have something on that right side, because I now need to get rid of my -12. So I'm going to add 12 now to both sides, and I have k is equal to 12, and that's my answer for that. Remember, you're going to plug it back in, and you're going to make sure that it works. Okay, this one here, you're confirming true or false if this is a solution. My best suggestion on how to solve this is to actually solve the problem. This is a hard number to try to go back and plug in for my x values. And then I've got a 5. It's not pretty. Nah, it's not going to be nice. Let's go ahead and just solve it and see what happens. Again, I'm going to get rid of my 12x first of all, and I'm going to minus that from both sides. So this gives me negative 7x plus 4 is equal to, that cancels out, negative 20. I'm now going to minus 4 from both sides. So I have negative 7x is equal to negative 24. I'm going to divide both sides by the negative 7 to get rid of my negative 7. Negative divided by a negative is a positive. Negative divided by a negative is a positive, but this would be 24 over 7. I would leave it like that because I can't reduce that. This does not match this here. So no, this is false. I do not have the correct answer. So that's the best way I can tell you to do that one. If you could plug it in, if it was that maybe it just said the answer was 5, that'd be an easy number to plug in, then I could do it that way as well to double check. Kind of like we said about checking your work. All right, solving for the equation. Again, I am going to get rid of the fraction on this one because that's actually the first step I have to do. So really what I'm going to do is just multiply both sides by 5 to get rid of the fraction. This part cancels out and I'm left with everything that's on top because again, this was 5 over 1 and that all cancels out. So we have negative 3y minus 6 is equal to 15. We now need to add 6 to both sides to get rid of the 6. Negative 3y is equal to 21. Then we're going to divide both sides by negative 3 to get rid of the 3. Negative divided by negative is a positive. Remember, too, we always do want a positive variable. Y is equal to, this is a negative. A positive divided by a negative is a negative. 21 divided by 3 is 7. So this is y equals negative 7. And again, think about plugging in your number and making sure that the signs are correct and everything. Okay, this one is asking about which value makes the inequality true. All right, when I solve this inequality, if I divide both sides by 3, there's nothing to do with my sign because I wasn't dividing by a negative or anything. So I have x is less than 7. The key thing is, ladies and gentlemen, I need all the values that are less than 7, not that equals 7. 7 is not an answer because I did not have this part of my symbol. I didn't have the little equals to part here. Okay? If I don't have that, 7 cannot be an answer. I'm looking for everything that is less than 7. Okay, oops, I got rid of too much there. But anyway, I'm looking for everything that is less than 7. I'm not looking for anything bigger or anything like that. 7 is 7. This is out. 8 is bigger. 9 is bigger. This here, ladies and gentlemen, is the only one that is correct. So please, please, please watch out. They might have something even where it's like click on all the numbers that would be true. So I could have picked anything that's less than 7. It could be 6. It could be 5. It could be 4. It could be 3. It could be 2. And you get the point. Okay? Next one. Write an inequality that represents at most 5 cookies. Okay, I always try to equate this to something that I'm doing. Okay, so I made Christmas cookies this weekend. So one of the things is write an inequality that represents at most 5 cookies. Well, maybe I made at most 5. That was the ones that I decorated. So I'm not going to do any more than 5. Can I do 5? Yes, at most I can do 5. But I can't do any more than 5. So I'm not going to have anything that's to the right of 5. I'm going to have anything to the left of 5. So think of a number line. And if I put 5 on it, I'm not putting anything this way. I'm putting everything this way. So that would be 4. That would be 3. That would be 2. That would be 1. I could have any of those. So my number then, if I'm looking at this number here, it's everything going in this direction. So my number for cookies is less than or equal to 5. This is my answer. Sometimes a number line helps. Just thinking about an actual instance, that helps as well. Number 18, Jaden plans to spend no more than $30 on 4 new binders. Think about it. He's not going to spend anything more than that. He has $30 in his pocket and he can't spend anything more, but he wants to buy new binders. So he can spend less than that or he can spend up to that, but he can't spend anything more than that. So which inequality represents how much he can spend on each binder? Well, at most, he's going to do 30 binders. So this is going to be where I'm having whatever it is on this side, 4 binders, or like 4B, is going to be less than or equal to 30. That means I now have to divide both sides by 4. And when I do that math, B is going to be less than or equal to 750. When you do the division, that becomes 750. So our answer is right here. So again, set it up as a problem and then solve to see your answer. All right, translate. Again, we're just translating. So the answers are going to vary slightly. We're saying 2x plus 10 is less than or equal to 3x minus 4. I could literally write it just like that, the way I just said it. However, we want to think about more than that. So where I'm going to think about this word here means sum. So I might say the sum of, and then I got to think of what I'm doing here. The sum of this here is twice the number. But it's the sum of this and 10. So the sum of twice the number and 10. This here, I could do a couple different things, is less than or equal to, is at most, and since we were kind of using that at most word, I'm going to use it again. Is at most, and then there's a couple ways I can do it. The difference of, I could say that for this part, like the sum of how I did that, or I could say the difference of 3x and 4, or the difference of 4, or I could say at most 4 subtracted is at most 4 subtracted from the product, because this time it's the product, well, it's this, I'm sorry, still the product, from the product of three and a number. And again, there's a lot of ways we could do it, because you could have said again the twice the number, or three times the number. You could have said it that way. There's a lot of ways you could have done this. All right, this is similar to what I was mentioning about before. It says to solve the inequality, number 20 here, and then check that each number that is a solution, and you have to check on all correct answers. All right, so we're going to solve it first of all. Remember, negative sign on the outside means -1 going to these two things here, the n and the -6. Or you can say the opposite of everything inside. That means -n plus 6 is less than 3n plus 6. Okay, I'm going to get rid of the 3n, so I'm going to minus 3n from this side. I'm going to minus 3n from this side. This side gives me -4n plus 6 is less than 6. I'm going to minus 6 from both sides. I get -4n is less than 0. Don't panic about that. Now I'm going to have divide both sides by -4. Remember, if I'm dividing by a negative number, I should hear a lot of bells and whistles going off in my head, because a negative divided by a negative is a positive, first of all. My sign has to switch, and anything that, 0 divided by anything is still going to be 0. So now what I'm looking for is all of my numbers that are greater than 0. The key thing, ladies and gentlemen, is from here to here. This here, this became a negative divided by a negative because we're dividing by a -4. That makes this sign change. You got to think about that. All right, so again, I want all the numbers that are bigger than 0. I can put them on a number line if I want to and do it that way, but remember, it's not going to be 0. 0 is not one of them. It's not going to be -1 because that's less than 0. 1 is greater than 0. 2 is greater than 0. 3 is greater than 0. 7 is greater than 0. Again, watch out what you're doing there with that. Okay, number 21, we are writing an inequality. So again, we're looking for we're doing the inequality type of thing here for this. 10 subtracted from a number. Okay, and when I say subtracted from, something's already there. This number is already there. So that means x minus 10. I cannot write this the other way because this is not a commutative property, ladies and gentlemen. Is greater than. This part here, oh, wait, or equal to, sorry, I'm missing something, or equal to, all of this is one sign. All of that is one sign. Is greater than or equal to. If you're having any trouble, ladies and gentlemen, knowing what your signs are, which way to point that arrow, draw yourself a number line. If I draw a basic number line like this, it looks like that. I have 0 in the middle, I have my positive numbers to the right, and I have my negative numbers to the left. As I move to the right, if I go this way, my numbers are getting this symbol right here, which is greater than. This is literally my greater than symbol. If I'm going to the left this way, then this symbol here is what I'm using. My numbers are getting less than. They're getting smaller because they're going into the negatives. So that's my symbol. This symbol right here is my greater than symbol right here. Remember, or equal to means I just have that line underneath. And this is my other number, 25. So that's my answer there. All right, this one here is, they love to do these kind of questions on an SOL where you have to click on all that apply, and they make you work out all these problems to figure it out. So it says to circle all inequalities that have the same solution set as shown in the graph. All right, well, first of all, what is the solution set? I have -3, and I'm saying that my values, I should say, for my x values are everything that is going this way, so it's everything greater than. Is it equal to? Is it equal to -3? It's not, because this is an open circle, so it's not filled in, so it's only greater than, but it's greater than -3. That means it's everything along here. That's what we're doing. So we're looking now to see which ones fit that. When I solve this, if I -5 from both sides, I get x is greater than -3. Okay, that's exactly what I want. So that one is a solution right here. I would circle this. This one here, I'm going to divide both sides by -2. We get x is, remember, I divided by a negative. If I multiply by a negative, I would also do this, but I got to flip my sign, and that's going to be a -3. I like this one too. This is x is greater than -3. Already done for me, and that is correct as well. Now I'm going to do this one. Divide by divide by +2 on both sides. That's x is less than -3. Be careful, that's a less than. I don't want that one. If I flip this all around, I get x is less than -3. Again, that's out. And then this last one here, if I flip it around, I get x is greater than -3, and that's what we just set up here. And so, yes, that one is also one I'm going to circle. All right, using the box below, label each step with the correct property that justifies how to solve the equation. Remember, ladies and gentlemen, they're going to have a question like this, and it's going to have a bank like this, a word bank. The key thing with this is the first thing that's given to you is given. It's literally given. So it says right here, given. This is the answer for that. It's given. That's my problem right here. That's the problem that's given to me. Now, what I'm going to do is I'm going to see what happens to go from here to here. I'm actually going to do some math. So I know that I would do this. I would do -4x and -2x and combine those, and I'm going to get -6x -3 is equal to 3x minus 6. And look at that. That's exactly what's written right here. Okay, so I did that step, and that is what I got. So what did I do there? If I look at all my choices, that is a simplify. Remember, combining like terms is the same as simplifying. So this here is my first step, so to speak. To go from my given problem to my step 1, this was simplify. All right, now what did I do to go from this step to this step? So again, I'm going to look and see what I do. I'm thinking that I'm going to subtract 3x from this side, and I'm going to subtract 3x from this side. And when I do that, oh, and by the way, wait a minute, I just realized I made a mistake. This is supposed to be a plus here, sorry. You need to change this on your paper. This is a +3 here, so that makes this a +3 right here. And this is still a +3 right here. And then this part is actually, this next step is wrong. There's a mistake, but I'll show you and we'll fix it. Okay, so so far I'm doing it correctly. So I'm getting rid of my 3x from here. -6x minus 3x is actually supposed to be -9x. So right here, put -9x, and that is what it's supposed to say. And then again, this was +3. Okay, for that one. So that step 2 should read -9x plus 3 equals -6. All right, so what did I do to both sides? I did this right here. I minus the 3x from both sides. So looking up here, it was a subtraction property of equality right here. I did it because I subtracted from both sides and I kept my equation equal. So this is the subtraction property of equality. Don't abbreviate like this on your test though. Make sure you're writing it out so we know what you're talking about. All right, the next one here, I'm going from here to here. And again, let's do what we're supposed to be doing. I'm going to -3 from both sides. So if I subtract 3, again, this was -9x is equal to, and that is going to be -9, because a -6 and a -3 is -9. So -9x is equal to -9. Again, though, it's the subtraction property of equality. Can be the same thing in a row. Oops, wait. That's not going to work. Okay, then we have our last step there, step 4. And what are we doing to go from here to here? And what we're doing is we are dividing both sides by -9. And so that gives me, this cancels out. We get x is equal to 1. Now again, what property did we do? This is going to be our division property of equality. Okay, so that's that one. Make sure you do know those different things we're talking about. All right, this one, be careful because now it's the same thing, but we have inequalities. So this time you got to watch your words. And for example, I have the word equality here. It can't be this. And I have the word equality here. It can't be this. We're not going to have any kind of equality because we clearly don't have an E equation. We have an inequality. All right, so I'm going to, again, I've got this given. What did I do to go from here to here? I'm going to -2 from both sides. That gives me 3x is equal to, oh, excuse me, is greater than or equal to 27. All right, so this here is going to be my subtraction property right here of inequality. So it's the subtraction property of inequality. Make sure you be careful with that part. Because if you write equation, it is going to be wrong. If you write equality, I mean, it's going to be wrong. Now, what do we do to both sides here? We're going to divide by 3. And when we divide, we get x is greater than or equal to 9. And so a division property, again, it wasn't division property of equality, it's the division property of inequality. So division property of inequality. All right, so that is your review. Again, make sure you're studying, make sure you are understanding all of it, and good luck on your test.